everyone who joined us for our first session. We are now preparing for our second, where our guest speaker is Kosseila Haddalene, who is an Oracle Ace Pro, has been with the program since 2021. He is a tech enthusiast and solution architect at CloudTrail with more than 17 years of IT experience. So Kosseila, welcome. You can already share your screen. I saw that you are here a couple of minutes ago.
Thank you. Hi, everyone, and welcome. I think I'm ready to go. I'm very glad to be speaking at Oracle Ace Conference. Today, we've got an exciting topic planned for you. I'm going to have to actually just rush because it's 25 minutes, so you can ask questions at the end. The exciting topics today that I have for you is bringing AI endpoint closer to your developers with local LLMs and how you can deploy them in a secure and private environment in Oracle Cloud. But before we dive into it, let me start with a quick intro. For those who don't know me, my name is Kosseila, aka Cloud Dude. I'm a founder and principal consultant at CloudTrail, a huge cloud and automation fan. I share all my labs and discoveries on my blog. That's cloud3.ca/blog, and also my GitHub repos. I have a lot of them. That's github.com/workdba. I also happen to host a podcast called TechPiece Unplugged. This is a QR code if you're interested. But let me actually introduce you to CloudTrail, which is actually my dynamic and boutique consulting firm. We're focused on DevOps and automation, cloud operation and migration, security and compliance, Oracle database, multi-cloud migration, be it XSCC, OCI, Azure, GCP, etc. Also provide corporate training, and which is timely, a brand new practice, which is private LLM implementation service. We actually didn't officially share that in our website, but take it as a premiere. But basically, we bring expertise in local AI inference deployment, whether it's OLAMA or VLLM. We'll talk about it later, both hybrid or in the cloud, ensuring 100% data privacy with full compliance, more control, with optimizing costs with open source models. So feel free to reach out to me at the end of the presentation if you want to learn more. But now that we're done with the intro, let's get for the reason why we're all here today. Okay, so quick heads up before the agenda. I created a GitHub repo where you can learn everything about OLAMA integration, open models, quantization in details, a lot of docs and information about it. Something to take away after the presentation. So you're welcome to check the QR code. Even the demo is inside that link. But overall, the bottom line of this talk today will be first about some context, like why proprietary AI models like OpenAI aren't that safe, and what open source models bring to the table in terms of privacy. And in section 2, we'll have an introduction on local LLM solutions, such as where to find them, how to use them, and briefly describe quantization. We'll also take a closer look to inference engines with a special focus on OLAMA, which is an essential piece for running local LLMs. We go through some features and capabilities, including running AI on CPUs. For some of you who don't know, but you can run LLM models on CPUs, which is super cool, via libraries like Llama CPP. And in section 3, we'll cover the steps to building a private LLM environment in Oracle Kubernetes Engine through automation, one being Terraform for cluster deployment, that's your Kubernetes cluster, and second, Helm charts for OLAMA backend engine setup. Right. After that, we'll jump into a quick demo to show you how to leverage the local AI API endpoints, that's the holy grail, to be used by your application. And finally, Q&A. I hope you'll have time. But let's get going. So why aren't these fancy closed models your BFF against? First, security. Why? Because as data could potentially be exposed to staff within OpenAI or even publicly, as we've seen in the past data breaches of 12% of plus subscribers. You also have external subprocessors like Snowflake that have access to your data. As for privacy issues, you got to remember that you give the right to OpenAI to train and fine-tune their models based on your own interaction with GPT, right? As written in their open AI terms of use. right? Another factor is cost. So where subscription can become expensive and volatile over time as you pay both for input tokens and output tokens, right? And even more if you're actually using reasoning models. Why? Because reasoning models, like they need to generate tokens. And guess who's paying those generated tokens during reasoning? You, of course. And the pricing models can change anytime as any other SaaS pricing model. Right? Add to this the lack of transparency, as it's hard to assess risks when the model is black boxed, and you have zero details about training data. Right. So as a result of all these risks, you shouldn't be surprised when you see not only countries, but Fortune 500 companies banning the use of ChatGPT or any regulated sector. As you can see here, even Microsoft bans ChatGPT use within their workplace. Right. So this is why open source models and local inference are gaining more and more adoption within companies from a variety of industries and different sizes. So what are these new alternatives? What is this open source sort of use of LLM models? Well, let's dive into it. Let's start with the what. Like, what are these open source or just open models, like some people call them, like Mistral, Llama, Qwen, Gemma 3, or DeepSeek? Well, these are freely available language models for personal or commercial use, right? Some of them have MIT license. Like you can see DeepSeek v3, most recent one from March 24, they got to some crazy benchmarks leveling up to Sonnet 3.7 or GPT-4o in major metrics with functions like reasoning, deep search, vision model capabilities, right? And one of the main benefits of OpenLLMs over closed models are the fact that they're modifiable, they're transparent, they're cost effective, and offer more flexibility with customization with full control of the lifecycle, like fine tuning, post training. You can actually run it in your laptop, your on-prem service without having to pay any license. And one of the things maybe most people get confused about is that Llama is free, but not actually open source, 100%. Right? Why? Because Olama provides the weights for free, some papers, but they will never give you or provide the training data sets, right? Unlike Mistral, that's 100% open source, right? So this is the difference. And one of the reasons you would never have access to the training data set of those model from Olama, for example, or even maybe OpenAI is the fear for a copyright lawsuit. As you can see here in this tweet, it's rumored that Meta has used more than 81 terabytes of pirated books just to train the data set. So, to their defense, it's really hard to share the data set if you got that kind of source. Right. So the other thing I really want to talk about today was quantization, right? Because this is, going to revolutionize the way we use LLM models. So LLMs have billions of parameters stored in what we call 32-bit floating point numbers. These are like full precision models. These require a lot of memory, right? You can see them, like, to store or run them. For example, a full precision 32-bit model requires 4 gigs of memory for every billion parameters, right? Take an example. Llama 3 70B, 70 billion parameters, right? You would require 280 gigs of memory in your VRAM just to load the model. We're not talking about context. We're not talking about any additional overhead, right? 280 gigs. This is where quantization comes to reduce the VRAM pressure by representing the parameters with fewer bits. They go down from 32 to 16 to 8, even 4, and even lower than this in order to run these models on resource-limited devices like small GPUs like L4 or even RTX in your own laptop or desktop. Right. And as you can see here in the table, like there's a original CCL floating 32 value. This is full precision. And the more you go down in terms of bits per weight, the more the precision, the accuracy actually will decrease. Right. But this is a trade-off between accuracy and size of the model. Right. And then in terms of types of for types and formats of quantization over the years, not so many though. You have FP16, that's like half of the bits. You have integer 8 with fixed points. Those are like methods for quantization with some performance loss. You have blockwise quants, as you can see here, Q4 0, Q4 1. They have quantization with scaling factors. And then you have a recent key quants. Key means key means, actually, right? So these are very popular and really, really used a lot by the community. And why? Because they offer like a dynamic allocation for better SAS performance. It tells you like 4 bits, but it's actually decided when to allocate 4, when to allocate more. But overall, the average is 4. For example, right? Q4 means 4 bits of depth, right? And the advantage here is that you have like a really, really granular sort of versioning of the models based on the ratio between the size and accuracy, right? But once you have them all, like once you have that model quantized, how do you assess it? How do you check if it's good or not? Well, there's something called perplexity. Perplexity is like doubt, right? So it's just a metric for prediction of accuracy. So the lower the perplexity, the better the text generation performance, right? This is how you sort of assess your quantized model. Other foundational models like non-quantized ones, they have all the metrics. You can see in the famous benchmarks, MMLU for general knowledge, human eval for code generation, GQPUA as well. So this is how you assess your model. But recently, we got actually some teams that actually went harder, more aggressively in terms of quantization. They went into a framework that would use 1-bit quantization for those models so that you would reduce the size really, really significantly. It's called, they're using, so like it's called BitNet, right, from Microsoft. It uses 1-bit LLM framework and it uses a library called bitnet.cpp. And they actually claim that they're faster in terms of inference on CPU and ARM chips than Llama CPP, which is yet to be confirmed. And they have a lower memory and computation. As you can see here on top, right? Llama 3 8B, they quantized it into 158 bits. So you already have examples of it, right? So this is really encouraging. But it's not over actually, because recently with the DeepSeek V3 that was released on March 24, a team from Unsloth actually quantized the model into a dynamic 271-bit GGUF quantization, right? And this actually allow them to reduce the size significantly, go into more than 70%, right? So the model, the original model that was like full 8-bit precision, right, has 720 gigs. And with this quantization to 271 dynamic quantization, fractional quantization, they got into 230 gigs, right? It's not going to run into a machine yet, your laptop, but still 70% is really, really encouraging. This is really promising for the future. So we won't have like full precision models that like can only run on GPU. You can reduce by like many folds the size of the model. This is very encouraging for the future. Okay, so where do you get the models? Right? If you want to play with open source models, there are 2 locations. The first one is Hugging Face with more than hundreds of thousands of pre-trained models for various tasks. You also have GitHub, which is a repo for community-based models. They have something called Marketplace. And the way you run those models, actually, since it's like Hugging Face is a repo, if you want to run it locally, you'd have to download the models and use PyTorch transformers library to run them locally. Right. So you would need to download files that we call weights. Right. So the PyTorch model here is a weight, right, done with PyTorch. You can have different ones as a Hugging Face ones as well, that model weights. And then you have something called tokenizer and vocab JSON. This is more like something that translates all your prompts into tokens so that could be treated by the model, right? And they have also config.json. So it's a scattered type of peripheral files that need to be downloaded and then run through PyTorch transformers, right? But then I talked already about GGUF. GGUF stands for GPT Generate Unified Format, right? So I explained the quantized models, right? So they also have like a format that allows to consolidate all those files into one, right? Take it as a zip file, right? Instead of having all those scattered files, you have a GGUF file that has everything, the weights, the tokenizers, and everything. See, the advantage is that it's future-proof format with better tokenization, and it's retro compatible with all older models, obviously. And it's optimized for CPU and GPU acceleration using the Llama CPP, right? So this is what we're seeing more and more lately. So this is just an introduction to the inference engines that we're talking about today, right? So this is one of the examples of the models that you can find in Hugging Face. So Meta Llama 3 8B, that's the name of the model, right? And if it's quantized, this is where the naming convention starts. Q4 means 4 bits depth per weight. K means the type of quantization, that's key means. M is the size. It could be S, M, L, and even lately XL, right? And then GGUF is just the extension of the file, right? So now we have the model. You can also check if you can run it in your machine based on your hardware, right? There's something called Can It Run LLM. You can check it. I'll share the presentation later, so because this is a link, you can see if it can run or not on your hardware. Then now this was just an introduction for inference engines. So like those files, now they can run into engines. This is what is actually responsible for the model to be sort of receiving your request, right? You have, unfortunately, we have a lot of choices. We have Ollama, that's a lightweight, user-friendly. This is our focus today. We also have VLLM. VLLM is an efficient production inference platform, multi-GPU, multi-node. Use it more for, I'd say, where you have like a high sort of concurrent use or batch processing, right? But it's not really for like a GGUF related models, or it's not for that kind of like on CPU type of inference, right? But it's more like the enterprise version. You also have local AI that's more closer to the CNCF landscape or ecosystem, and you have LM Studio. LM Studio is like an all-in-one. So you do inference, and it's like your VS Code as well, right? It has a GUI interface that provides a developer experience as well, all in one, right? Now, we talked about them. Our focus today is Ollama. As I said, it's lightweight, user-friendly, designed for manual resource consumption, simple to set up and operate, supports almost 28 quantization or even more. And the advantage here, like one of the benefits, is that it's really ideal for beginners. If you never used inference, Ollama is the go-to solution for small scale projects, for example. Why? Because they have a huge community behind them. They have a release every 2 weeks. So really, really huge community. And it's really, really ideal for quickly deploying LLMs on your own hardware, actually. Now, like we talked about Ollama, but we're talking about how to bring AI API closer to developers. But what do developers care about? Well, API endpoints, right? So Ollama API had 3 endpoints. The first one is generate. That's more of a text completion, summarization, like where you have like a fixed a task, and then they have API chat. If it's a chatbot, you will use that API endpoint for multi-tenant conversation. And then the third one is API models. That's more for managing remotely the models that are in your backend. Like you can list, pull, update, delete models, right? And the default port, listening port is 11434. That's the main port. You can change it obviously, but that's the known port like that is used by Ollama is 11434. Right. As an example, you can see here that you can deploy Ollama in a Docker or Kubernetes or anywhere you want. Actually, it would start to listen on that port. You could pull and run GGUF Llama model. That's like around 5 gigs. And then you would have on the right side, this one, you have the stream application that would interact with that API endpoint. That would be your web application, your front end. So this is just one example. Now, building private LLM endpoint in OKE, you have choice. You have 2 sort of flavor. The first one is creating your application from scratch. So your backend, once your backend is downloaded, is deployed, your Olama LLM backend is deployed, you have the choice to create an application from scratch using client Olama Python library that would interact with your backend. Here, as an example, is just Streamlit for UI. As you can see here in the small diagram, you have Olama backend that is already running on your OKE. It has like a PVC. You pull the model. You have a GGUF Llama model, same example that we did before, and Streamlit would just be another pod in your Kubernetes cluster. The second one is eventually if you want to run a chat pod that has from the open source community, right? So you don't want to reinvent the wheel. If you don't want to reinvent the wheel, you can use Open WebUI, which is like a super famous. It used to be called Olama WebUI. It's super famous project with tons of contributors, tons of features like integrated rack, like Google search, like web search, including the chatbot. So you can use that. And the advantage here is that you can run Helm charts to deploy it the same way you deployed the Olama backend. Right. So here, as you can see here, you have the inference server, you have the service. So this will expose the backend within your cluster, right? That's the base URL, what we call the base URL, right? And then this part would just download the models automatically. So like the Helm charts of Olama would just deploy a model already, and then your Open WebUI will listen in 8080 or will be, for example, presented through an ingress to your customers or your end users, right? And then the OpenWebUI, we just use the service name just in order to interact as an API endpoint. So the base URL here is key8 service. It could be ingress as well. As you can see here, if your application was outside your Kubernetes cluster, you would have to use ingress, right? As like the base URL, right? These are the two examples that we have. And now we got to the demo. So demo time, I hope we have 5 minutes to show the API example real quick. But basically, first one, you have the OKE that would be very simple to install using my fork repo as shown in my blog post. That's number one. And number two, once you have your Kubernetes cluster running, you can actually deploy your Olama backend through Olama Helm charts, right? So this is the two links. And now hopefully I can switch actually to the second window just for a quick preview of the demo. Let me see, where is it? Yes. All right. Okay.
All right.
So the first
Great.
link was my blog, just to tell you about the OKE Quick Start fork on GitHub. The repo is BrockDB Terraform example, right? And the model is under. Right, so this is my fork of quick starts, right? So basically what you need to do, these are just simple instructions. You clone the repo. This is the OKE part, right? And you go to OKE quick stars, Terraform init. I put a source file where you can define the version of Kubernetes, the number of worker nodes. If you just want to play with it, fine. You can specify it here, specify the cluster type as well. So once even the shapes of the workers, right? Once you define all those values, you can source that file, run Terraform plan, and then Terraform apply, and boom, this is all automatic. You will have your cluster available with the OKE resources. So boom, now you have your cluster. And now you can get to sort of the fun part, because the fun part is the Olama backend, right? Olama has a Helm chart in Artifactory, and then you just need, once you have access to your cluster in your terminal using kubectl, for example, so you have the credentials, all you need to do is using Helm repo, you add Olama Helm, right, through the URL, you update the repo, and then you install the deployment of Olama by specifying the namespace. You can choose anything, but here I choose Olama, and then the values. So these values will decide the type of backend you have, right? This is the same link I shared in the agenda slide. So I put a link to all the values available, but you don't have to go through all of them. I have my own that is very specific to OKE. As you can see here, while the parameters is GPU enabled, my cluster is CPU, right? It's not GPU cluster, right? So like I don't have the money for GPU, so what do? I actually just go to this parameter, I specify false, and then You go down, you get to values where you specify the service. So you specify the port, the node port. This is how you expose the backend to the application that are within your cluster, right? And then further, you can also specify how you like the values for the hosts where you expose your backend to the outside world, right? As you can see here, that's the ingress. This will use your load balancer for OCI, right? And once this done, there's the little part where actually I define the parameters. As you can see here, there's a system message for my model. Once I download it and I run it through Ollama, right? I tell him, system, you are a helpful AI assistant named Elmo Assistant, right? Once this is done, there's one very simple example that you can go and test your ingress just to see if like in terms of networking it works. It's called Page Assist. So Page Assist is a Chrome extension, even Firefox extension that plays your open web like a web UI for Ollama, right? It's a chatbot. You don't have to install anything, just the extension, right? So this is like freely available. It's like super lightweight. And if I go back, this is the interface actually of Page Assist. It's not my application, it's just an extension. I go to Ollama setting. This is my ingress URL, right? So this is the base URL that I choose. And once I do it, you know what I mean? I go back here and I go to a new chat, right? So just to tell you that I'm using that address and say, hey, hi, what is your name? Right? If I do that, since I specify already that, see, my name is Elmo. Remember what I showed you that I put the system message here as Elmo. So this is a proof that I'm actually talking to that model that is running in OKE, right? Another example with the same link that I shared earlier in the presentation in my repo, which is freely available. It's a chatbot created through Streamlit, right? So all the code is in there. The Python library of Ollama has something called Ollama, a module called client, and this is where you choose the base URL. So this base URL is, if you don't specify it, it will run locally. It would assume that you have a local host sort of endpoint, right? If you have a different one, different port, different URL, you have to specify this one. And once it's done, I can show you actually is that I'm in my VC. What is it? So this is, for example, my ingress, right? So my ingress IP URL is this one running on OKE, right? And I go back to my application running on my laptop, right? And then I just have to run Streamlit, run Ollama chatbot. We're talking about the same, like it's inside this application within my repo, right? So all I had to
So
do
Kosseila,
was actually
we just
running
have
this, and now it has a local host. You see, it has a local host endpoint or front end, right? And what this does is it will connect to my backend in OKE. And this is done from scratch, right? So I guess, hi, what is your name? Just to confirm that it's the same one. Maybe this one takes a bit longer than the page assist, but basically this is communicating with the same OKE backend, OKE Ollama backend, right?
Can
Nice
you
to
hear
meet
me?
you. My name is Elmo, right? So this is more or less the two examples that you can try once you have the OKE, the Ollama backend deployed in OKE with the ingress URL, and you choose this as a base URL, right?
Can
So
you hear
this
me?
is what I want to
And
to
can any
to
of the
share. Let me go
links?
back to my Prezzo, right? So those are the two links. The first one is how to deploy OKE in a sort of opinionated way, but very easy, super quick. And the second one is the Helm charts, so you can just sort of check the QR code and think I'm actually done. If
Yes.
you feel free to reach out to me, LinkedIn or anywhere about this Ollama Lab, know more about quantization, learn more also about Cloud3 if you're interested. On the right side, you have the Ollama Lab repo. This is where I put everything, even more than everything. And on the left side, there's like a blog. If you guys are interested in quantization, how does that work, and what are like all the new terminology, I created a blog called a quantization, all you need to know, and that could be maybe instructive for you. But I actually hope this was informative for you, and Thank you for having me. If you have any questions, feel free to shoot.